let's just get right into it. So we're going to be talking today about indefinite and definite integrals. What is the difference between an indefinite and a definite integral? So we can talk about that first. We're going to get started with indefinite integrals because that's typically what you start with in calculus. Let me write that down. That's a horrible I. Indefinite integrals. These are problems that look like this. First, you need to know how to draw the integral symbol. It looks like a long S, something like this, and then we have some function, like let's say x, and then we have to cap it off with like a dx. So if I were to talk about an indefinite integral, this is what it looks like. Integral, function, dx. A definite integral is going to look something similar, except it's going to have bounds. I'll say what I mean by that in a few minutes. But first, let's take the integral of this. So what is an integral? Well, an integral is the opposite of a derivative. And if you're good at derivatives, then hopefully you're good at integrals. And if you're not good at derivatives, well, then you have absolutely no hope with integrals. So make sure you're good with that first. So let's do this one first. X dx. If I were to ask myself, what is the antiderivative of this? First, I would ask myself, what is the derivative? And let's take another function like x squared, like a function like x squared. If I were to take the derivative of this, I would say to myself, okay, well, I'm going to pull this 2 out in front here, and then I'm going to say the 2 minus 1 power. It's going to become 2x now to just the first power. And this is the power rule. We have a similar rule for indefinite integrals, and that is, well, the power rule for antiderivatives. Notice this is x to the first power, right? So I just need to do the opposite of what I would do for a derivative. So I'm going to add 1 to the power, and then divide by that power. So divide by 2. Instead of multiply, divide with integrals. So this will become x squared divided by 2. And then at the end of any indefinite integral, we always need to put plus c. Where does that plus c come from? Let's talk about that. So first, I just want to say the nice thing about integrals is that you can check your answer to any question that's an integral. How, you ask? By taking the derivative. And if you take the derivative and you get the original function, which again was just x, then you know you got the right answer. So let's do that right here. I'm going to ask myself, what's the derivative of x squared over 2? So following the power rule, the 2 goes out in front, times x now to the first, and then we divide it by 2. The 2's cancel, and you just get x. In other words, this is the correct answer. Now, what about the plus c? Well, I have a question for you. What if I had x squared over 2 plus 1, and I asked you what's the derivative of this? Well, you'd say the derivative of x squared over 2, we just said it, it's x. And what's the derivative of plus 1? It's just plus 0. The derivative of plus 1 is 0. Now, what if I had x squared over 2 plus 10? What's the derivative of that? Again, just x. Notice any number I plug in here, even if it's like minus 1/7, the derivative is going to just be x. And technically, I shouldn't draw equal signs. I'll draw like these arrow things, meaning that these are the derivatives. But the point is clear. Plus c we need to include because it could be any of these three. How do I know that the integral is not plus 1 or plus 10 or minus 1/7 or just 0? Right? It could just be plus 0 in the first place. And so to cover every possible situation, we just put a plus c at the end of it, and that covers every possible answer we could have. And yes, you need to put plus c at the end of every indefinite integral problem. Okay, so that's it for the first one. Again, what did we do? We did the power rule essentially backwards. Any questions so far? Okay, great. We've got 20 more problems tonight, and I promise you this, it's going to go much faster than the review, which took, 100 minutes? It was an hour and 40 minutes. So here we go. Here's the next problem. Integral of 3x squared dx. I want to take the integral of this. So again, what am I going to do? Well, first I see this 3 here. What do I do with the 3? It's a coefficient, right? So I'm just going to first pull it outside of my integral because it's just a coefficient. I can do that. As long as it's not an x, as a matter of fact, I can pull it out in front. So 3 integral of x squared dx. Now all I need to do is the power rule. So again, instead of subtracting 1, I'm going to add 1 to the power. And then instead of multiplying, I'm going to divide that by my new exponent, which is 3. This integral will equal 3 because that's, well, the coefficient right there, times x cubed divided by 3. And again, we need a plus c at the end of every problem. These 3's cancel. You're going to get x cubed plus c. That's our final answer. Any questions? Okay, let's keep going. Integral of quantity 7x minus 4 dx. Just a quick point on notation. You do need to include parentheses here. Like if I miss the parentheses like this, it would be like forgetting a comma in your sentence. It's grammatically incorrect. So for that reason, you need parentheses between the integral and the dx. Now, notice we have two terms here. We have 7x and we have the minus 4. So what I'm going to tell you is we're just going to take the integral one at a time. So for instance, what's the integral of 7x? So again, this 7 is going to be a coefficient. So I just pull it out in front of my integral. And then the integral of x, we kind of started with it. But if this is to the first power, I add 1. So now x squared. And then divided by that power, so divided by 2. There's the integral of 7x. Now, what's the integral of minus 4? This is a little bit trickier. Well, actually, it's pretty easy if you know the rule. So if there's no x, I repeat, if there's no x, like minus 4, then that means the integral is you just add x to it. So it's minus 4x. That's it. That's the rule for just constants like this. And then we're going to add c, and pretty much that's our answer. And one more thing I want to say about that minus 4, that integral of minus 4. If I had the integral of 5 dx, well then that integral would just be 5x. If I had the integral of 11 dx, well then that integral would just be 11x. Oh, and I forgot the plus c, sorry. But that's the point. If you don't have an x in your integral, you just add one and that's the integral. There you go. Easy. Any questions so far? Okay, great. The next one I want you to try on your own. I'm going to give you like 30 seconds, a minute to solve this next one on your own. It's the integral of x divided by 2 dx. I'm sorry, the x cubed over 2 dx. Okay, go ahead and take some time to solve this. If you get stuck, because maybe you're wondering what do you do with this divided by 2, I just want to tell you, remember, you don't have to do quotient rule. This 2 in the denominator is the same exact thing as if you had a 1/2 x cubed dx, right? Like these two things are equivalent. And then the 1/2 is just a coefficient. So go ahead and try this on your own. I'll give you another 30 seconds and then we'll talk about it. Okay, even if you're not done yet, I'm just going to start talking. So this integral is going to be, again, the 1/2 is just a coefficient. I pull it out in front, times the integral of x cubed is going to be x to the third plus 1 divided by that power, 4, and then plus c. And this can simplify to x to the 4th power in the numerator, 8 in the denominator, plus c. There we go. There's our integral. Again, the hard thing about this one, I would say, is sometimes you do see divided by 2 like this. And a lot of times this scares kids. I don't know why. But all you need to do is rewrite it as a 1/2 and then we're good to go. And here's one more before we start looking at some of the annoying ones. Well, actually, this one's kind of annoying. I have the square root of pi dx. What is the integral of this? Notice, is there an x here? No, it is just pi. So if some of you think that we should rewrite it as pi to the 1/2 power, which you could do, I mean, this is true, this would be equivalent, it's not necessary because all we need to do, since there's no x, we just add an x next to it, square root of pi times x plus c. That's it, that's the integral, because pi isn't a variable. Okay, any questions so far? Great. Now let's get to the annoying ones. Instead of the square root of pi, now I'm going to give you the real one, square root of x dx. Ah, darn. Everyone hates this one. I like it because it makes me a lot of money. Because people hate it. Now, the square root of x, now we are going to rewrite it as x to the 1/2. We are going to rewrite it as x to the 1/2 because we are going to need a power rule now. So now I need to ask myself, what's 1/2 plus 1? A lot of people think way too long about this question, so here's what I would recommend you do. 1/2 plus 1 is the same thing as 1/2 plus 2/2, right? Which is 3/2. So this integral, or the integral of this, is now x to the 3/2 power divided by 3/2 plus c. Now we can't leave this as the final answer. We don't like complex fractions like this. We don't want to have a fraction within a fraction in the denominator. So instead, how do we deal with that? Well, I'm just going to flip it. I'm going to take the reciprocal and multiply. So the reciprocal of 3/2 is now 2/3. That's times x to the 3/2 power plus c. That's a much better looking final answer. And yes, I'm going to do that all the time. And if you want to, and you see that you're dividing by 3/2 and instead you just want to go straight to multiplying by 2/3, you can do that too. I'm typically going to write out the intermediate step though, that 3/2 in the denominator, just so you guys are following along. Okay, any questions? Okay. Next one, another down-home favorite. We have the integral of 1 over x squared dx. So there's two ways you could do this. One is the quotient rule, and two is rewriting this with a negative exponent. I recommend doing the second one for two reasons. Number one, it's better to rewrite this as a negative exponent, like integral of x to the negative second power dx, because now it's a simple power rule, right? This is easy. The other reason you don't want to do quotient rule for this one is because quotient rule doesn't actually exist with integrals. That's right. Quotient rule, product rule, and chain rule don't exist in integrals. They only exist in derivatives. Well, then how do we deal with a problem like that if we had derivatives, product rule, quotient rule, or chain rule? How would we take the integral of that? That's a great question. We're going to be talking about it later today. So stay tuned. So first, let's take the integral of this, x to the negative second power dx. Some people will say, well, we all know we're adding 1. Some people will say x to the negative third power. Those people are fools. They're not paying attention. Negative 2 plus 1 is minus 1, and then we divide it again by minus 1 plus c. You can keep this as your final answer. If I was your professor, I would accept this. I would also accept 1 over negative x plus c. And why would I write it like this? Well, because x to the negative first power is just 1 over x. Okay? So this is acceptable to write as well. Any questions so far? Okay, great. The next one here is another one I'd like you to try on your own. It's not fun, I promise. Unless you like fractions, which I'm assuming is none of you. We have the integral of x to the 4/5 power minus 1 over x to the 2/3 power dx. Oh, need to put this in parentheses like this. Okay, now I'm going to give you a minute to start solving this. I'm also going to give you a 30-second head start, and then I'm going to start going. I won't talk. I'll let you keep going. I'll just be quiet, but I'll start writing. And you know what? I'm going to stop talking right now. Just go ahead, try this integral. I'll catch up with you in a second. Okay, time's up. Again, if you didn't get an answer, that's fine. But let's talk about what we did here. So first, hopefully you did x to the 4/5 plus 1, which is also 5/5. So you got 9/5 for that power, which is how I got x to the 9/5 right here. Again, divided by 9/5, and we can even see in the next step that I rewrote it as 5/9 here, like that. Hopefully that makes sense. We're all good. And then for the x to the 2/3 power in the denominator, remember, that can be rewritten as x to the negative 2/3 back in the numerator. So what I did was I said negative 2/3 plus 1, or 3/3, is equal to now positive 1/3. That's how we get x to the positive 1/3 divided by 1/3, which really is the same thing as multiplying by 3 over 1, which technically 3 over 1 is just 3, so I don't even need the divided by 1. And there we go. That is the answer to this one. And don't forget the plus c, of course. Any questions on this one? Okay, I promise we're done with the crazy fractions for now. But next we have a fun problem, and I say that truly honestly. So far we have not been solving for plus c, because normally we don't need to. However, it's possible that we can solve for it, especially if the question's essentially implying that they want you to solve for it. What do I mean by that? Let's say this problem. I have f prime of x, I'm going to give you the derivative, is equal to x to the fifth minus 6x plus 2, all divided by 2. Then I'm also going to give you the point f of negative 1 equals 4. Notice this is not the derivative, this is the original function. And what I want you to do is I want you to find what f of x is equal to for this function. So one of the most important things to realize for, well, derivatives and integrals, if I give you the derivative, then how do I find the original function? That's why we have the integral. So what I'm asking is, what's the integral of x to the fifth minus 6x plus 2 divided by 2, and let's find this integral first. So the first thing I'm going to do is with this divided by 2, again, this is not a quotient rule. We don't have quotient rule in integrals. Instead, I'm going to treat this like a 1/2 all the way out in front. So it's like 1/2 times the integral of x to the fifth minus 6x plus 2. Need to put that in parentheses, dx. And again, it's a 1/2 out in front because that 2 in the denominator is essentially just a big 1/2 to all those terms. So now I can take this integral. It's not too bad. 1/2 times x to the fifth. Well, that's now going to be plus 1, so x to the sixth over 6. Hopefully you're getting the hang of it now. I can start to go a little bit faster. Okay, the next one's kind of annoying actually. But this minus 6, that's just a coefficient. I'm going to write it out in front. And then the integral of x is, well, if that's x to the first power, that's going to be x squared over 2. I can simplify that in the next step. And then what's the integral of plus 2? Well, remember, there's no x there, which means for the integral, we just add an x. It's 2x. And then, of course, we have plus c. Oh, and I need to be careful here. So pretty much where does the end parenthesis go? It's going to go right here. In other words, this 1/2 is being applied to everything except plus c, because the plus c goes at the very end. Okay. This can simplify a little bit. I'm going to also distribute the 1/2 to every term at this point. It's not too bad. So I'm saying here I have x to the 6th divided by 12, because 2 times 6 is 12, minus, notice here I have 6 divided by 2, which is 3, but then I'm still dividing by 2, so 3/2 x squared plus 2 times, actually, 2x divided by 2 is now just x, so that's easy, and then plus c. Okay, great. We have our equation for f of x. Only one problem, the plus c, we don't want it. And the reason we don't want it is because I gave us an initial point. F of negative 1 equals 4. In other words, negative 1 is our x point, 4 is our y point. We can just plug this into the equation, solve for c, and let's see what we get here. So in other words, I'm saying I'm plugging 4 in on the left and negative 1 in for x. So it's going to be negative 1 to the 6th divided by 12 minus 3/2 times negative 1 squared plus negative 1 plus c, and again that equals 4. This is not going to be friendly numbers. I don't know why I did this problem, but it's not that bad. Negative 1 to the 6th is now positive 1/12 minus 3/2 times negative 1 squared would just be 3/2 times positive 1 now, so it's still minus 3/2. Then minus 1 plus c. This isn't too bad. Let's get a common denominator of 12. So on the left, 4 times 12 is 48. Is that right? Yeah. 48/12 is equal to 1/12 minus 3/2. We need a common denominator of 12, so I'm multiplying by 6 over 6. 3 times 6 is 18 over 12. Minus 1 is the same thing as 12/12, and then plus c. This is not very friendly. Do I want a calculator? No, we don't need it. So 48/12 is equal to, on the right, 1 minus 18 is negative 17. Minus another 12 is negative 29 over 12 plus c. Now I just need to add 29/12 to both sides. So 48 plus 29 is 60, 77/12. That's c. Okay, great. Now the last step you need to do is just write out the full equation. F of x is equal to my original function, which was what? X to the 6 over 12 minus 3/2 x squared plus x plus c, and we're plugging in c with 77 over 12. So x to the 6th over 6 minus 3 halves x squared plus x, and then plus 77 over 12. That was a mouthful, but there you go. There you go. That problem wasn't too bad. Honestly, if I were to do it again, I wouldn't have chosen such ridiculous numbers, but the lesson is still the same. The way we solved this problem is we took the integral, then to solve for c, we had to use our initial point, which in this case was the point f of -1 equals 4. The x point was -1, the y point was 4. Any questions on this one?
How'd you get 48 over 12?
That's because so at this step, I did what's 12 times 12, I asked myself to get the common denominator, and 12 times 4 is 48.
Oh, so wait, what were you trying to get the common denominator between the 4 and...
I was trying to get a common denominator between all of my terms. So like 4, -1 to the 6 over 12, 3 halves times -1 squared, and -1. The biggest common denominator would be 12.
So then you multiplied everything by that.
Exactly. And alternatively, you could just plug this in your calculator, and that's obviously what I would encourage you to do on the test. But I like mental math. I'm old-fashioned that way. I don't kiss before marriage. You know, that kind of stuff.
Okay, thank you.
Yep. Any other questions?
I have one question. How did you get like the 12 in the denominator in the first place?
Yes. So that was back in this step right here. I distributed the 1/2 to every term. And where did the 1/2 come from? Right here in the original problem.
Okay, thank you.
Yep. Any other questions? Okay. Yeah, that was a hard problem. Or at least it was annoying. The numbers were annoying. Okay. So that's it for the indefinite integral. Again, everything here was indefinite. In other words, it had a plus c at the end. Now we're going to look at the definite integral. Definite integral. And it is definitely harder than the indefinite integral. Ha ha ha. So why is that? Let's look at a problem. Let's say I have the integral from 0 to 2 of x dx. You see right away what the difference is. I have bounds. I said the integral from 0 on the bottom, 2 up top. What on earth does that mean? So first we need to talk about what the integral means in general. Let's say I have the function x here. Okay, it's a pretty straightforward line. It's just a slope of 1, y-intercept 0. Here's y equals x, right? So now if I were to ask you what's the derivative, let's go back to the very beginning of the year with derivatives of easy functions like this, and I were to ask you what's the derivative, you would tell me 1. The derivative of x is just 1. Hopefully you know that by now. If not, I don't know how you made it this far. But the derivative is 1. And what does derivative mean? Slope. In other words, if I were to ask you what's the slope of this line at any point, you would just tell me 1, because that's what the derivative means. Derivative, that's not a D. There we go. Derivative equals slope. Now we're talking about integrals, right? So we need to ask ourselves, what does an integral mean? So I'll just tell you. If I'm asking you to solve for the integral from 0 to 2 x dx, maybe you know this already, but it's going to be right here. If this is 0 and that's x equals 2, it's the area under the curve. In other words, it looks like the area of a triangle in this case, because we know what the function is. And that's exactly what integral is. Integral is area under the curve. And what is the curve? It's just the function. It's just another word for the function. Okay. And so what we're going to be doing with integrals, and actually what we've already done so far, is we've found the area at any x point. Like all the functions we had before that were functions of x, and you add a plus c at the end. I mean, you would need to know the coefficients exactly to find those areas, and you would need to know your x values. But with definite integrals, we're actually going to know what the exact area is because we have these bounds. So let's go ahead and solve this one now. Now, luckily, the strategy starts out exactly the same. If I were to ask you what's the integral of x, we've already done this one. It was the first problem of the night. It's x squared over 2. You add 1 to the power, divide by 2. Now, here's the difference. Don't put plus c. Oh no, this is not what we're doing. Instead of plus c, I'm going to draw a long vertical bar like this Up top I have a 2, at the bottom I have a 0, and now I'm going to ask myself, what is this integral? I'm going to plug in 2 for this quantity and then subtract when I plug in 0. Here's what it's going to look like. 2 squared divided by 2 minus 0 squared divided by 2. That's all it is. So 2 squared divided by 2 is just 2 minus, well, the right term is just 0. We're going to get a final answer of 2. In other words, that's the area. That's the area between 0 and 2 for the function f of x dx. Just to prove it real quick, I'm going to go back to my function, and if I were to ask myself, what is the area of the black shaded region here? Well, first I need to find my height, and to find that height, we would actually just plug in x into the equation y equals x. Notice the y point's just 2. It's pretty straightforward. And if I were to ask myself, what's the area of this triangle? We'd say 1/2, because it's 1/2 base times height. 1/2 base of 2, height of 2. One of these sets of 2's cancel. You'll get a final area of 2 using just geometry. And you can use geometry if you can. You don't need to plug it into a function. But as you can imagine, for the rest of the problems here tonight, and pretty much for the rest of this course, it's not going to be this easy. Okay, so the next one we have another definite integral. It's the integral from -1 to +1 of the cube root of x dx. So instantly, the first thing I'm going to do is rewrite cube root as x to the 1/3 power. So -1 to +1 of x to the 1/3 dx, just like that. Okay, now if I ask myself, what's the integral of this? I need to add 1 to 1/3, 1/3 plus 3/3, because I need a common denominator, is 4/3. So now this is going to be x to the 4/3 power divided by 4/3, which again I can rewrite as x to the 4/3 times 3/4, the reciprocal, right? We talked about this. And then I need to take the bounds. I have 1 up top, -1 on the bottom, and again I'm going to plug in 1 first into x and then subtract when I plug in -1. Now I'm going to tell you this, you have 2 options here because we have a coefficient of 3/4. I'll write out both and you can decide which one you like. The first way is I would say the straightforward way. You can say 3/4 times 1 to the 4/3 power minus 3/4 times -1 to the 4/3 power. That's one way you can write it. The other way, you can also factor out the 3/4 right from the beginning and just say 1 to the 4/3 power minus -1 to the 4/3 power. This is going to be the exact same answer. Which one do I like to do? Well, I like to factor out personally, but if you think the top one's more straightforward, then do that. I don't care. Now, if we were to plug this in a calculator, or even if you didn't need a calculator, it's 3/4 times 1 to the 4/3 power is just 1 minus -1 to the 4/3 power is positive because the 4th power makes it positive again. Again, I'd encourage you to just plug in your calculator. I don't care. But it's going to be 1 minus 1. In other words, we're going to get a final integral of 0. How does that make any sense? Well, it actually makes pretty good sense if you think about it. Now, what does this function look like, the cube root of x? Maybe you actually don't know what this looks like. I'll tell you. It looks like this shape right here with a vertical tangent line at 0. In other words, I tried to draw it like completely vertical at x equals 0. Clearly, I can't draw, but I did my best, and that's what counts. And I'm looking at x equals 1 to -1. So if I think of this area, I'll draw this area in red on the negative side, and then the same area in blue on the positive side. Again, I'm just not good at drawing, but essentially the red equals the blue. The two cancel out because they're exactly mirrors of each other. It's symmetrical. And that's not going to happen all the time, but this is why it happened. This is why we got 0 for this case. Any questions on that? Okay, great. Now there's one more I have for you guys. I'd like you to solve this one on your own. It's the integral from 1 to 4 of 2x squared minus 3 dx. Okay? So I'm going to give you a minute to do that, and I'm going to start writing around the 30-second mark. Okay, I'm going to stop you guys here, wherever you're at. At least I'm stopping myself here because at this point the rest of it's just algebra. But just to quickly recap what the integral was, it's 2, because this 2 is a coefficient, we write it out in front, times the integral of x squared, which is x cubed over 3, using the power rule. And then since the next term is minus 3, there's no x, I just add an x there. That's what the integral is. Hopefully you didn't have trouble with that. You do need parentheses here, again for notation purposes, and then long bar, 4 up top, 1 on the bottom. Then we're just plugging in 4 into the first spot, and then subtracting when we plug in 1. Notice here I put another set of parentheses when I plugged in 1 because you do need it. That negative sign right here needs to be distributed to both terms. A lot to remember in terms of notation, but all of it very important. I'm not going to torture you guys this time like I did the last time. I am just going to plug this in my calculator. 2 times 4 cubed divided by 3 minus 12 minus quantity 2 divided by 3 minus 3. I got a final answer of 33. I don't know how this came out to be a round number, but this should be it. Any questions on this one? Okay, so now at this point, we just finished all the definite integral problems I wanted to look at tonight. And now I want to show you a shortcut method that's going to solve integral problems in literally no time at all, but it's a cheat method. Okay, if you have to show your work, this is not going to give you like any credit at all. Okay, and the professors know this. I want you, if you have a, wait a minute, what kind of calculator are you allowed? It's not TI, it's not a graphing calculator, is it? Yeah, no, it's not. But just if you're curious, you can check your answer while you're doing your homework or anything where you can use a graphing calculator. If you have it within reach, I'm going to tell you to hit Math 9. And what that would pop up on your calculator, I'm going to hold it up to my camera. Hopefully you can see it. It actually looks like a little integral there. And what you would do is you would actually plug in the bounds, you would plug in the function, and then you'd put a little x at the end, and you can actually find the exact answer in literally no time at all. Only caveat for that is, on most calculators, like TI-84s, you can't do this for indefinite integrals. The plus C stuff, this won't work. This will only work for integrals with bounds. That's how smart the calculator is. If you have a TI-89 calculator, though, it can do indefinite integrals as well. But, I mean, no one in their right mind has that. Only a couple of my friends ever had a TI-89 calculator, and they were all super nerd engineering majors. So don't follow our path. Go down whatever path you're on right now. Okay, so that's it for definite integrals. Now the next topic I want to talk about is U substitution. So I looked at the notes for U substitution and how they show it in the textbook. And I don't understand how that's even allowed to be released to the public. That explanation for U substitution was so horrible, so horrendous. I'm pretty sure you're actively becoming dumber just looking at it, how confusing it is. I don't even remember what it is, how they explained it, but I'm going to explain it my way. It's going to make sense, and that's all you care about anyway. At least that's what I care about. I don't care about the grade. I care about if things make sense, honestly. If you can try your best in this class, even if you fail, well, obviously you don't want to fail, but if you at least try your best in this class, that's all I care about. And if I can make that suffering a little bit less, well, then I'm making the world just a little bit of a better place, and that's always my goal. Okay, enough of the sappy motivational stuff. Back to the problem. We have the integral of x squared minus 4 cubed times 3x dx. Again, this is going to be a U substitution problem. U substitution. Now, how do I know this is U substitution? That's a great question. So U substitution is going to show up whenever you have one of the three cases. A product rule, which is what we have here, a product rule. A chain rule, which is also what we have here. Or a quotient rule. If it looks like any one of these three rules in the integral, in this case we have two of the three, which is really bad, it means we're going to use a U substitution in order to solve the integral. And the reason we do that is because we don't actually have a product rule or a chain rule or a quotient rule with integrals. We just don't. Sorry. But I've got good news and bad news. The U substitution is more fun than all of those three rules. It's less memorization like you would for those three rules. The bad news is because it's more free form. It's kind of like jazz. There's a lot of choice on your end in terms of how you solve these problems. And for that reason, if you don't know what you're doing, it's really hard, if not impossible. But luckily, we're going to be going over a bunch of examples today, so I don't think that will be a problem. So let's start off by picking a u. I need to choose a value for u, and I guess it's a good point. You have no idea what u to pick. U could literally be anything here. So I'm just going to tell you what the right answer is at first, and then we'll talk about why. I'm just going to tell you, let u equal x squared minus 4, the thing in the parentheses right here, okay? U equals x squared minus 4. Then I need to take the derivative, not the integral, the derivative. And I'm not going to say u prime. I'm going to write du dx, and you do not have a choice here. You have to write du dx, not u prime. And you'll see why in a second. But the derivative of du dx is going to be, well, derivative of x squared minus 4, that's just 2x, right? So I have du dx, it's 2x. And actually what I want to do here is I want to solve for dx. So I'm going to multiply both sides by dx. On the left, I just have du. On the right, I then have 2x dx. And then I just need to divide both sides by 2x. And we'll end up getting dx equals du divided by 2x. Dx equals du divided by 2x. Now, why is this important? Well, I'm going to plug in this value for dx right here into my integral, and I'm also going to plug in u equals x squared minus 4, into that spot right there. The 3x I'm not going to touch. I'm going to leave it as 3x, and here's what this integral is going to look like now. It's going to be the integral of, now instead of x squared minus 4 cubed, it's just u cubed. Much easier. 3x stays the same, and then dx, we just set it down here, it's du divided by 2x. Du divided by 2x. Now, how on earth did this help us? This looks more complicated. Well, I'm glad you asked. So the goal of a u substitution, first of all, is to make the integral simpler. The second goal is to make sure we cancel out all of the x's so that we're only left with u's. Notice here I have a 3x in the numerator and a 2x in the denominator. The 3 and the 2 won't cancel, but the x's do, because this x is in the numerator, that x is in the denominator. And also with this 3 and this 2, I'm going to write out in front as coefficients a 3 in the numerator, a 2 in the denominator, times the integral of u cubed du. So sure, this might not be x cubed dx, but it's the exact same thing except we're dealing with u now. And so what I'm going to say is the integral of this, and by the way, this is an indefinite integral, right? Because there's no bounds. We're going to get plus c at the end. So it's 3 halves, because that's the coefficient, times the integral of u cubed is going to be u to the 3 plus 1, so 4, divided by 4, and then plus c. Now, this is not the final answer quite just yet, and that's because our final answer cannot have u in it, because we started with x's. So the last step, plug back in x squared minus 4 for u. I can also simplify the coefficients. So that's going to look like 3/8 times the quantity x squared minus 4 to the 4th power plus c. This is our final answer for the u substitution. And again, good news, we can check our answer by taking the derivative, right? Now, for this problem, I mean, I'm not going to lie, this is not easy to take the derivative, but if you were to take the derivative, you would end up with your initial problem in the integral, which was x squared minus 4 cubed times 3x dx. Any questions on that one? We're about to do a bunch more u substitution problems. Oh, one more thing. Why did I choose u equals x squared minus 4? Let's talk about that, because that's actually a good point. So I'm going to tell you there's a few different options I could have chosen, right? I could have chose x squared minus 4, which I did. I could have chose x squared minus 4, the whole thing cubed. I could have chose that. I could have just chose 3x. How do I know it was x squared minus 4? Here's what I'm going to tell you. I like to use the Goldilocks Principle. It's a theory I made up, patent pending. And it pretty much says for a u substitution problem, you don't choose the thing that's too short. You don't choose 3x. You don't choose the thing that's too long. You don't choose x squared minus 4, the whole thing cubed. You choose the thing that's just right, which is the thing in the parentheses here. And most of the time it is the thing in the parentheses. It's usually the thing in the middle. And of course, you could be wrong. If you are wrong, well, first, it sucks because you have to redo the whole problem. But how do you know if you're wrong? We'll talk about that later too. So next, let's just do another u substitution problem. Just get in the swing of things. Let's say I have the...
Sorry, I just have a quick question.
Go for it.
The last one.
Mm-hmm.
How'd you get the 3 halves in front of
Right.
in front of it?
So that's because when I got it from this step. So 3 right here is in the numerator. A 2 right there is in the denominator. and I just wrote it out in front like a coefficient.
Oh, okay. Thank you.
Yep.
I was also just confused on how you got your u with the du dx.
What are you saying? How did I get this u, or how did I get the du dx?
How'd you get the u solving with it by the du dx?
I'm kind of confused by that question.
Just like, how did you get what was it, 2x, whatever you got for u?
That was because 2x is the derivative of x squared minus 4, and du dx is the derivative.
Okay. Makes sense.
Okay, good. Okay, next question. I have the integral of, in the numerator, I have 4x squared. In the denominator, I have quantity x cubed plus 1, and that's all going to be squared, okay? So once again, it's a U substitution problem. How do I know? Well, it's just a mess, and plus we clearly have a quotient rule and a chain rule going on here. So I need to choose a U for my U substitution. What should I choose? I'll give you like 5 seconds to take a guess on your own. Don't say it out loud. And the correct answer is x cubed plus 1. Pretty similar to the last one, so hopefully you got it. And if not, no big deal. We'll talk about what to do when you get it wrong in the next problem, but for now we're still right. We're 100% accurate. And the next step after you choose your u, we need to solve for dx, which I actually forgot to write in the problem. There we go. So to find dx, I need to say du dx, my derivative, is equal to the derivative of x cubed plus 1, and the derivative of x cubed plus 1 is just 3x squared. Now once again, I need to solve for dx, so I multiply both sides by dx. Du will equal 3x squared dx, and then divide by 3x squared. Dx is going to equal du divided by 3x squared. I'm going to plug in the dx right there, and I'm also going to plug in my u, x cubed plus 1, right there in the denominator. So what does my integral look like then? It's going to look like, what do I do with the 4x squared in the numerator? Nothing. I leave it alone. I hope it cancels out. In the denominator, I have u squared now, and dx just got replaced with du over 3x squared. So similar to the last problem, the x squareds will cancel out. The 4 and the 3 do not cancel out. They're going to be written out in front of the integral as 4/3 as a coefficient times the integral of 1 over u squared du. Now we're still not ready to take the integral yet because that u is in the denominator, but the reason how I know I chose the right u for the u substitution is because, do I have any x's left over in this integral? No. And that's how I know I chose the right thing. If I chose the wrong thing, I would have x's left over. It'd be no good, and we'd have to start the problem completely over again. Very fun when that happens. Okay, so before I take this integral, I need to rewrite it as u to the negative second power du. There we go. And so then I'm going to say this is equal to 4/3 times the integral of u to the negative second power. Again, I need to add 1. So it's u to the negative first power divided by negative 1 plus c. Again, I can rewrite that if I want to now as negative 4/3 times 1 over u plus c. And the last step, of course, is to say, what is u? U is going to equal x cubed plus 1, so there we go. We get a final answer of negative 4/3 times 1 over x cubed plus 1 plus c. And there we go. Any questions on that one?
How did we go from the du to the c?
Let me see. Right, you mean at this step, right? Here to the next step?
Yeah.
So just in general, when at this step, I took the integral in the next step. And whenever you take the integral, you lose the integral sign and you lose the du, and it gets replaced with plus c.
Okay.
But that's a
And
good
then
question.
how did
Because a lot of people forget that, and then you have some people who put du plus c, and those people are just so wrong, it makes me laugh. What were you about to ask?
and then how did we get the negative 4/3?
Yeah, so I kind of,
Like,
it's from this negative 1 in the denominator. I just wrote it out in front.
oh, okay. Thank you.
Yep.
I'm still kind of confused on how you're getting your, like, I get that you get the derivative from u, but
Yes.
like the whole du over dx thing is like, how'd you get du on the top over 3x squared?
Okay. I want to know where I'm losing you with this. So this makes sense, I'm assuming. Does this step make sense?
Yeah, the first derivative does.
Okay, now, we've never seen this before because, well, we never had to do it, but du dx can actually be broken up. Even though, like, why would we do that? This is the derivative. We're breaking it up right now because we need to solve for dx. So what I did was I multiplied both sides by dx. The dx is canceled there, and I still had to multiply dx over here. That's how we got here. And then what did I do? I divided by 3x squared on both sides.
Okay, that makes more sense.
Good. Any other questions? Okay. So now, as promised, the next one I'm going to purposely mess up because I could not make a mistake unless I clearly tried to, because I'm perfect. That's usually not true. Whenever I say that, it's usually within the next 5 minutes I actually make a mistake, not intentionally. So I need to be careful about bragging in that way. I've been pretty good this semester, though. I haven't been bragging that much. That's probably not true. For those of you who know me well, yes, I brag in every lesson. But I deserve it. I'm the best. So it's not bragging, it's the truth. Okay, so now with this one, again, I'm going to purposely choose the wrong thing. Also notice that, well, for this integral, 2x plus 2 times quantity x squared plus 2x, technically we don't even need a U substitution. If we wanted to, we could FOIL everything out and then just do a series of power rules to find this integral. But since this is the U substitution lesson, I'm going to use a U substitution. So I need to choose U. Let's say I'm an idiot and I have no idea what I'm doing, and I say U equals 2x plus 2, because that's what I think U needs to be. Then du dx, the derivative, is equal to 2. I should have also warned you from the beginning. Since I'm doing this the wrong way, feel free, instead of writing this down and then erasing half a page of work, if you just want to kind of watch and learn, that's fine too. So du dx is going to equal 2. Again, I need to solve for dx. So I multiply both sides by dx. Du equals 2 dx. And then dx, I divide both sides by 2 to get dx equals du divided by 2. Okay. Now again, I plug in dx right here. I'm going to plug in u right there. We're going to get the integral of u times quantity x squared plus 2x times dx is now du divided by 2. Now, first of all, notice nothing canceled, but that's not necessarily the problem. I don't need stuff to cancel. The bigger problem is just the fact that I have these x's left over that did not cancel out. And since I have x's left over, this is entirely wrong, and I'm going to erase everything I just wrote. Luckily for me, I have my handy-dandy, cheater tools here. But for you, you'd have to cross everything out. It's very annoying. Okay. So this, instead, the correct U substitution is x squared plus 2x. I'm going to go relatively quickly here since we essentially did this already. But du dx is equal to derivative of x squared plus 2x is 2x plus 2. Then I'm going to say du is equal to quantity 2x plus 2 times dx. I multiply dx on both sides. And then the next step is divide both sides by 2x plus 2. dx equals du divided by 2x plus 2. Now let's see what happens when I plug everything in. I'm going to get the integral of quantity 2x plus 2 times now just u times dx is now du divided by 2x plus 2. We see that the 2x plus 2 will cancel, which is nice. And now we're just left with the integral of u du. This is a very easy integral to solve. It's going to be u squared over 2 plus c. And again, we said u was x squared plus 2x. Final answer, quantity x squared plus 2x squared divided by 2 plus c. Okay. Any questions on that one? So now for the next one, we're done with U substitution with indefinite integrals, which this is when you say, uh-oh, because that's right, we're doing definite integrals this time with U substitution. Now, is it harder? Yes. Is it that much harder? I'm going to say kind of. So 4x minus 6 This whole thing's going to be cubed, and then we have dx. So first of all, notice this could be a definite integral or an indefinite integral. Like, the only thing that's different between a definite and an indefinite integral takes place after we take the integral. What am I trying to say? The process for U substitution is pretty much exactly the same. I just choose my U, I find du dx, I plug in, I cancel out, I hope that the integral works, and then I take the integral. All that stays the same. Now, what do I choose for the U here? Notice I can't use my Goldilocks method. Oh no, because I only have two things here. I have the thing in the parentheses, and I have the thing in parentheses cubed. I think you can guess this, but if you can't, you know what happens already when you choose the wrong thing. So I'm going to tell you U is going to equal the thing in the parentheses, as it is most of the time. It's a good rule of thumb. It's not every time. A lot of it is trial and error until you start to pick up the pattern of choosing the right U. But in this case, U is going to equal 4x minus 6, which means du dx, the derivative, is equal to the derivative of 4x minus 6, which is just 4. Then multiply both sides by dx, du equals 4 dx, and divide both sides by 4. Dx equals du divided by 4. Perfect. Now I'm going to plug in for dx and for u. I'm going to get the integral from 1 to 2 of, now it's u cubed, u cubed times dx is now du over 4. This is when you say, uh-oh, nothing canceled, and you would be correct. Now, did I choose the right u for my U substitution, though? I did choose the right U substitution. How? Well, it doesn't need to cancel out. Remember, the x's just need to be gone. Do you see any x's here? Nope. Then we chose the right U. Perfect. So this is going to be the integral of 1/4 integral from 1 to 2. Oh, and it's 1/4 because this 4 is in the denominator, and it's a coefficient, and I pulled it out in front. So 1/4 integral from 1 to 2 of u cubed du, and I know this integral because it's essentially what we've been doing all night. It's the 1/4, again, the coefficient, times u to the 4th divided by 4. I added 1 to my exponent, so 3 plus 1 is 4, divided by 4. There we go. And then again, I'm going to plug in the bounds 2 to 1. Now, if you plug in right now, you're going to make a huge mistake. What's the mistake? That's a rhetorical question. You don't need to answer it. I forgot to plug in for u. Don't forget that. Also, this 4 and this 4 in the denominator, I can combine to just be a 16. So it's 16 in the denominator. In the numerator, 4x minus 6. 4x minus 6 to the 4th power. Okay, great. So now all I need to do is plug in the bounds. 2 minus 1. We're going to get 4 times 2 minus 6 raised to the 4th divided by 16 minus 4 minus 6 raised to the 4th divided by 16. Let's see what this is. So 4 times 2 is 8. 8 minus 6 is 2. And 2 to the 4th power is 16. 16 sixteenths. That's actually just 1. Pretty cool. Minus 4 minus 6 is negative 2. Negative 2 to the 4th power becomes positive 16. Positive 16 over 16. Look at that. We actually just get a final answer of 0. Ain't that cool? Yes, Dan. Okay, thank you. Thank you. Now, there's one more thing I want to say about this problem. I'll give you another second to write down. Now, there's one more thing I want to say about this problem, and that is there's another way of solving it. Do you remember back when we were doing extrema and we said we had the first derivative test with the number line, and then we had the second derivative test, and everyone liked the first derivative test, and we all collectively hated the second derivative test, but then sometimes we were forced to use the second derivative test? Well, we're going to have those exact same feelings right now, where the method that I just used, where we plug in back for u, and we plug in the points, that's one way of solving the problem. There is another way, and it's called, I don't know if it has a name, but this is what I call it, change the bounds. Change the bounds. So I would say, from like a very technical perspective, this is the right way to solve an integral. And the way we did it before was technically wrong because the bounds, when we use a U substitution, we need to change the bounds or else it's technically not correct. Now, will your professor care? No, of course not. No one cares. It's kind of an intermediate step. As long as we plug in x at the end, it doesn't matter. We get the same final answer. But sometimes you'll see questions where they ask you, hey, change the bounds. So that's a good question. Let's talk about that right now. So when it says change the bounds, and we did the U substitution, u equals 4x minus 6. We said u equals 4x minus 6, and we had the integral from 1 to 2. I don't care what was inside it right now. Let's just stick with these facts. Integral from 1 to 2, we said u is equal to 4x minus 6. Technically, what you need to do to change the bounds, you actually plug in 2 and 1 into my x points and find the new bounds. So this would be u equals 4 times 2 minus 6. I'm just plugging in 2 here into the u. My upper bound is now 8 minus 6, so positive 2. It actually stayed the same. Pretty cool. And then my lower bound would be u equals 4 times 1 minus 6. My new lower bound would then be negative 2. So in other words, if I had the integral from 1 to 2 in dx form, where I had, whatever the function was in the middle, then my new integral is the integral from negative 2 to positive 2, and that's when we have du. Again, I don't really care about this. Like, you don't need to solve it this way unless it specifically asks you. They wouldn't say change of bounds formula or anything like that. They would literally ask you, what are the new bounds after you use a U substitution? They would ask you, what are the new bounds after you do the U substitution? And for that reason, there's actually another way we can solve this problem. And it goes back to this step right here. I'm going to rewrite it down here. 1/4 times u to the 4th divided by 4 evaluated from 2 to 1. This is what we said, right, at some point in the problem. Now, if we want to, and we completely have the choice, we have two options at this stage. Number one, we can plug in for u, which we said was what again? Let me scroll up. 4x minus 6. U equals 4x minus 6. We can say that. We plug in for u. We did exactly what we did for this problem. The other thing we can do is, instead of plugging in for u, I can change my bounds, 2 up top, negative 2 on the bottom, and now I actually don't have to plug in for u. I can keep it in u. And just to prove we get the same answer, it's going to be u to the 4th over 16, because the 4 times 4 in denominator is 16, evaluated from 2 to negative 2. I plug in 2 here, 2 to the 4th over 16 minus negative 2 to the 4th over 16. You plug that in a calculator, you're going to get 16 sixteenths minus 16 sixteenths. It's 0. You get 0 both times. And again, the reason I compared this to the first and the second derivative test is because I think, or at least in my opinion, I don't like the change of bounds method compared to the just plugging back in for x method, because that's how we solved all our other integrals today. We actually just plug back in for x. It's easy. However, when the question asks you to change the bounds, that's when you have to do it this way. So any questions on this? I know I just said a lot. Any questions? Okay. So
I just had one.
Yep.
It's like kind of like the first step. I'm kind of confused with this. Like where you plug u into like the very first step in the last problem we did. Yeah. Like u to the 3rd. That's.
You're saying right here, u to the 3rd?
Yeah.
Yes. And that's because u is 4x minus 6. So I'm replacing.
Oh, okay.
You got it?
You replace the u. Okay.
Yeah.
Wait, no, I don't.
Okay. It's here. I'm gonna try and take. I'll try one more time to explain, and if it still doesn't make sense, we'll just stay after because we're almost done today already. Okay. But what I'm saying is u is equal to 4x minus 6. So I replaced 4x minus 6 with u, and when I do that, I have u cubed. The dx got replaced with du over 4 because I solved for that down here. The dx equaled du over 4. Does that make sense?
Yeah.
Are you sure?
Yeah.
Okay.
Yeah.
Good.
Thank you.
Yep. Any other questions? So now
I have one question.
Go for it. Yep.
Sorry. So when we plug back in our u, so like for the first example, like our u is 4x minus 6. So when you plug that in, why did you raise it to the 4th power instead of the 3rd? Like, where did the cube go?
It's because that was before we took the integral. Once we take the integral, you add 1 to the power. Right?
Oh, okay. Yeah, that makes sense.
Okay. Yeah, a lot of people, I'm not going to lie, this is a common mistake I see. A lot of people spend like 5 to 10 to 15 minutes on just the U substitution that they forget to actually take the integral. Don't forget to take the integral. It's a separate step to the U substitution. Okay. So now for the any other questions? Speak now or forever hold your peace. Okay, for the last set of problems we have today, I want to talk about more area under a curve questions, except this time I'm going to give you the graphs themselves, because this is another way we can find area under a curve. We don't always need to do calculus. We don't always need to use integrals, right? If we know the shape using geometry, like equations of triangles, squares, semicircles, whatever, we can actually just find this area the old-fashioned way. So let's look at some examples. I have here a coordinate axis x and f of x. And let's say I have this shape right here. I have a triangle going up like this, and then that triangle starts to go down like this. I need to give you some points here. So the point where it crosses the x-axis, that point is 4. At the very end, that point is going to be positive 6. I then need to give you the y values. The y value down here, like the tip of the triangle, has a height of -4 for f of x, and the tip of this triangle has a height of positive 6. Now what I want to ask you to do is, if this is f of x, I want you, without any function, to find the integral from 0 to 6 of f of x dx. So hopefully you see what's going on here. When I ask for an integral of the function, and I don't give you a function, integral just means area under the curve. So if I add the region of these two triangles, then we're good. Okay, so the first one, the big triangle that has it's an equation 1/2 base times height. So 1/2 times the base is 4 times a height of 6. Hopefully we all see that. So that's going to be 1/2 times 4 times 6, which is 12. Great. And now for the triangle down here, it's going to again be 1/2 base times height. A base of 6 minus 4 is 2, and then the height is -4. Notice here, the area for this triangle will be negative. It will be negative, and that's important. So the 2's cancel, we'll get a final area of -4. So in other words, my integral from 0 to 6, f of x dx, is literally just the area between these two triangles. 12 minus 4, final answer 8. No calculus, or at least no real calculus involved. Any questions? Yeah, so this was probably the most friendly problem we had all night, right? Yeah. Well, don't worry, it gets worse. Here's the last problem I have for you guys, and then we'll wrap up early today because there's not too much more to talk about. I think this is it, honestly, for like at least the next week. So I have another set of coordinate axes here, x and f of x, just like this. I have the following shape. I'm going to draw it. Okay, it looks like this. Now, instead of giving you the x values where stuff is happening, I'm just going to give you the coordinate points. Over here, all the way on the left, is the point 0, 2. At this elbow right here, that's the point 3, 2. Down here, at that point, that's the point 5, -2. And then at the very end, I'm going to give you the point 7, -2. Now, for this one, I'm not going to ask for the integral. I'm going to ask specifically for the area under the curve. Now, what's the difference? That's a great question. So technically, it's a different question. Why? Because integrals can be positive or negative. Integrals can be positive for some parts, negative for the others. The proof's in the pudding for the last problem. It was a positive triangle and a negative triangle. But if I ask you for what's the area under the curve, that's a different question. The area, I'm going to put this in parentheses, area must all be positive. They do not need to tell you that. This is just the definition of area under the curve. Area must always be positive if they ask specifically for the area under the curve. Is it confusing? Yes, I know. I apologize. I did not make these rules, clearly. But if I wanted to find the area under the curve now, it's just going to be the shape of these two, shapes right here, and it's all going to be positive. Okay, so I can split this up, notice, into a rectangle and a triangle over here, and then another rectangle and a triangle over here. So as long as we can find these shapes, we're good. So first I'll shade in this rectangle in blue. The blue rectangle has a width or length or whatever of 3 times a height of 2, because that's how high it is. So we have an area of 6 for the blue. Then I'll say this triangle in red. Notice here, I don't know how long this is, do I? Like, I don't have this point where they intersect. I did that on purpose because I want to see if you guys can find it on your own. I'm going to give you 30 seconds to think about how we can find either the x-coordinate where this graph intersects, or just in general the length of this triangle, and by extension the length of this triangle. So I'll give you 30 seconds to think about that. If you can't get it, it's no big deal. Go ahead and go. Okay, and time's up. Put down your pencils. So, or don't, because you're about to pick them up again, because we're going to be writing. So for the red triangle, and just in general, what we need to figure out is we need to figure out the slope of this line. We need to figure out the slope of that line. The slope is equal to the rise over the run, right? I see that I'm going down 4. 1, 2, 3, 4 to get from positive 2 to negative 2. So the rise is negative 4. The run, I'm going from x equals 3 to x equals 5. So the run is 2. In other words, my slope is negative 2. And here's why that's important. I'm going down 2 every x point. So if I start at positive 2 and I go 1 to the right, I'm now at 2 minus 2. I'm at the 0 point. What I'm trying to get at here, the point is x equals 4. It's x equals 4. Then we go down another x point. We go down another 2. That confirms that, yes, it is 4. And again, I did that by finding the slope. Now, if this method is confusing to you, I know I didn't explain this the best that I could have. I don't think it's the biggest deal in the world if you don't understand it. But just try and listen to this explanation again later tonight or tomorrow. Watch the YouTube video. Give me a like and a subscribe while you're at it. Thank you. Thank you. Now, why is this important? Because now I can find the area of the red. The area of the red is going to be a base from x equals 3 to x equals 4. That base is 1. Oh yeah, and it's 1/2 out in front. 1/2 base times height. So 1/2 times a base of 1 times a height of 2. The area of the red is just 1. So now I have 2 areas. I have 1, I have 6. Now I just need to find the area of these last 2 shapes. I'll say this triangle in green next. I am running out of room. Let me clear some space for myself. There we go. Okay. So for the green, here, let me draw in black. That's better. So for the green, notice I have 1/2 base times height. The base is from x equals 4 to x equals 5, which is a base of 1, times a height of negative 2. But again, I asked for area under the curve, which means they want me to give all positive numbers. So again, this is going to equal positive 1 because the 1/2 and the 2 cancels. Now we just need to finally find the area of this last, let's say, yellow rectangle right here. And that rectangle has a base of from x equals 5 to x equals 7, which is a base of 2, times a height of negative 2, which I don't care about the negative, so just keep it positive. We'll get a final area of 4. Now, my final answer to this question, I just need to add all the areas together, keep them positive. It's going to be 6 plus 1 plus 1 plus 4. Final answer for the area is 12. Okay, thank you all for sticking around. This is it. You are free to go home.